Did you know there's a machine so complex, so mind-bendingly difficult to build, that only one company on Earth has ever mastered it? It's called an EUV lithography machine, and it's the absolute pinnacle of human engineering. These machines are the magic wands that create the powerful computer chips inside everything from your smartphone to supercomputers. For years, the world's most advanced economies, including the United States and Japan, have poured billions into trying to build their own, only to fall short. The prevailing wisdom was that if anyone could do it, it would take them decades. But just recently, a shockwave rippled through the tech world. Reports emerged from a secretive laboratory in Shenzhen, China, confirming the unthinkable. Against all odds, Chinese scientists have reportedly built a working prototype of an EUV lithography machine. This isn't just a small step, it's a giant leap that could redraw the entire map of global technology. Insiders are calling it China's Manhattan Project, a testament to the sheer scale and secrecy of this monumental achievement. So what exactly is this machine, and why is it so important? Imagine trying to draw a detailed map of an entire city onto a grain of sand. That's essentially what an EUV lithography machine does. It uses a super powerful, highly focused beam of extreme ultraviolet light to etch incredibly tiny patterns, called circuits, onto silicon wafers. These circuits are the highways for information in a chip. The smaller you can make them, the more you can fit onto a single chip, and the faster and more efficient it becomes. We're talking about features measured in nanometers. A nanometer is 1/1,000,000th of a meter. To give you some perspective, a single human hair is about 80,000 nanometers wide. The latest chips have features smaller than 5 nanometers. Creating these microscopic patterns requires a level of precision that is almost beyond comprehension. The heart of an EUV machine is its light source. This isn't just a fancy light bulb. To create extreme ultraviolet light, the machine fires a high-powered laser, 50,000 times a second, at a tiny droplet of molten tin falling through a vacuum chamber. Each laser strike vaporizes the tin droplet, creating a plasma fireball hotter than the surface of the sun. This explosion releases a burst of EUV light. But here's the catch. EUV light is absorbed by almost everything, including air and even standard glass lenses. So the entire process has to happen inside a perfect vacuum. And instead of lenses, the machine uses a series of ultra-smooth, multi-layered mirrors. These aren't your everyday bathroom mirrors. They are the most perfect mirrors ever created by humanity, polished to an atomic level of smoothness. If you were to expand one of these mirrors to the size of Germany, the largest bump on its surface would be less than a millimeter high. Any tiny imperfection would distort the light and ruin the chip. The light is bounced off this series of mirrors, focused, and then projected onto the silicon wafer to create the circuit patterns. The coordination of the laser, the tin droplets, the mirrors, and the wafer stage has to be synchronized with picosecond accuracy. That's a trillionth of a second. It's an engineering ballet of unbelievable complexity. Until now, the only company capable of performing this ballet was ASML, based in the Netherlands. ASML has a complete monopoly on EUV technology. They've spent over 2 decades and tens of billions of dollars perfecting their machines. Each machine costs over $200 million, weighs 180 tons, and requires multiple Boeing 747s to transport. Access to these machines is tightly controlled. Governments see them as critical national security assets, and due to geopolitical tensions and trade restrictions, China has been completely cut off from buying them. This embargo was meant to slow down China's technological progress, especially in advanced sectors like AI, supercomputing, and military technology. The theory was simple. Without the most advanced tools, you can't make the most advanced chips. For a while, it seemed to be working. China's top chipmaker, SMIC, could only produce chips that were several generations behind the industry leaders like TSMC and Samsung, both of whom use ASML's EUV machines. This is what makes the news from Shenzhen so revolutionary. For years, experts in the West dismissed the idea of China building its own EUV machine. They pointed to the immense technical hurdles, the vast supply chain of over 5,000 specialized suppliers that ASML relies on, and the decades of accumulated knowledge. The consensus was that China was at least 15 to 20 years away, if they could ever succeed at all. But behind the scenes, China was mobilizing. It launched a massive, state-funded national effort, pouring billions of dollars into research and development. It brought together its brightest minds from top universities and research institutes, like the Changchun Institute of Optics and the Shanghai Institute of Optics and Fine Mechanics. This wasn't just about throwing money at a problem. It was a coordinated, strategic push to achieve self-sufficiency in a critical technology. They broke down the EUV machine into its core components: the light source, the mirror system, the vacuum chambers, the precision mechanics, and began tackling each one systematically. The recent reports, first appearing in the South China Morning Post and citing insiders and scientific papers, suggest that this massive effort has paid off. A key breakthrough came from Tsinghua University, which developed a new type of light source based on a principle called steady-state microbunching, or SSMB. While different from ASML's approach, it's a legitimate and potentially more efficient way to generate the required EUV light. This wasn't just a theoretical paper, they built a working facility and proved the concept. The prototype machine, reportedly developed by the secret lab in Shenzhen, is said to be capable of producing chips at the 28 nanometer node. Now, 28 nanometers is not cutting edge by today's standards. The latest iPhone chip is made using a 3 nanometer process. However, this is a huge misunderstanding of the achievement. The first ever prototype doesn't need to be the best. It just needs to work. It proves the concept. It proves that the impossible is possible. Think of it like the Wright brothers' first flight. Their first plane only flew for 12 seconds and covered 120 feet. It was nothing compared to a modern airliner. But it proved that powered flight was possible. That first success opened the floodgates for rapid innovation. China's 28 nanometer prototype is their Wright Flyer moment for EUV lithography. It demonstrates that they have mastered the fundamental principles and overcome the most daunting technical challenges. From here, the path to smaller nodes like 14 nanometers, 7 nanometers, and beyond is an engineering challenge, not a fundamental scientific one. It's a process of refinement, scaling, and improvement. And if there's one thing China has proven over the past few decades, it's their ability to iterate and scale technology at a breathtaking pace. The implications of this are enormous. If China can successfully commercialize its own EUV machines, it completely neutralizes the West's primary tool for containing its tech industry. It means China will be able to produce its own advanced chips for its smartphones, its servers, its AI data centers, and its military hardware, free from any foreign control. This would create a parallel tech ecosystem, one that is not reliant on Western technology. The global semiconductor supply chain, already fragile, would be completely reconfigured. We could see a world with two independent, competing tech superpowers, each with its own capabilities from design to fabrication. For consumers, this could eventually lead to more competition and potentially lower prices. But for geopolitics, it marks a seismic shift. The technological Cold War just entered a whole new phase. The West was betting that China couldn't climb this mountain. They set up roadblocks and controlled the path. But it seems China didn't try to climb the mountain, they just built their own. This development is a stark reminder that you can't ban knowledge. When a nation of 1.4 billion people puts its mind to something, you should expect the unexpected. The race for technological supremacy is far from over. In fact, it may have just begun. Thank you so much for watching. This is a story that's still unfolding, and we'll be keeping a close eye on it. If you found this explanation helpful, please hit that like button and subscribe for more deep dives into the technology that shapes our world.